innovative infrastructure technologies for electric vehicles. In the transportation industry, innovation typically refers to new IT systems, like geospatial recognition or automated control. Yet under the hood remains the internal combustion engine, hardly innovative. Fortunately, electric vehicles have become more mainstream, and along with them infrastructure like charging stations. Yet even plug-in chargers are far from innovative. 21st century transportation demands real innovation to make EVs easier to charge and less range limited. With new infrastructure investment, as well as the need to alleviate climate change, it's prime time for out-of-the-box transportation technologies. Two technologies offer opportunities for EV infrastructure innovation: linear induction motors, or LIMs, to enable long-range travel, and inductive power transfer, or IPT, to make charging seamless and safe. LIMs and IPT can be key elements of infrastructure now, without requiring new technology development. When powered by renewables, both LIMs and IPT can reduce emissions from transportation. Linear induction motors have seen only limited application in the US. NASA studied LIMs for rocket launch assist, and the Navy has deployed them on aircraft carriers. Despite these developments, LIMs have remained outside of mainstream transportation. LIMs can provide EVs with essentially unlimited range, using an aluminum plate on the undercarriage. Conceivably, highways with LIM lanes could allow EVs to go from New York to LA on a single charge. By eliminating the need for stored power over long distances, LIMs can reduce EV charging cycles and thereby extend battery life. Further, regenerative braking conserves energy and reduces brake wear. Linear motors also enhance safety, since acceleration, speed, spacing, and braking are all fixed. And, since LIMs have no moving parts, they're easy to maintain. Linear motors can also be deployed on runways to provide assist during takeoff as well as regenerative braking during landing. LIMs can also be installed on taxiways to minimize using engines designed for flight. Thus, LIMs can save fuel and reduce both aircraft emissions and noise. Takeoff and landing assist using LIMs will be even more important for next-generation electric aircraft. Inductive power transfer, or IPT, has likewise had limited application, primarily being used to charge small electronics. Although IPT is used in Europe to wirelessly charge electric buses, charging EVs in the US continues to rely on old-fashioned hardwire plugs. Nevertheless, IPT offers easy and convenient battery charging. And, since it eliminates physical connections, IPT also affords greater safety, particularly during poor weather. Wireless power can also be used for non-EVs, such as tractor-trailers at rest stops and recreational vehicles at campsites. Like linear motors, inductive power can also benefit aviation. Wireless power for aircraft at gates or on taxiways can save fuel for flight, rather than wasting it on the ground. During extended delays on the tarmac, IPT can help avoid returning to the gate to refuel. Inductive power also provides greater safety for airport ground crews, especially in rain or snow. And also, like LIMs, IPT mitigates engine noise at airports. Revitalizing transportation infrastructure and reducing emissions are imperative. Both can be addressed through innovative technologies like linear motors and inductive power. New jobs would also be created in construction, manufacturing, and the auto and airline industries. Overcoming today's transportation and environmental challenges will depend on truly innovative technologies. Both linear motors and inductive power can help make sustainable transportation a reality for the 21st century.